Regarding the first one, I wanted to find the point of continuity and the point of discontinuity of the functions. We know that this is a rational function. It's for number one, it's a rational function. Its denominator is 2, right? So I can't plug x with 2. Negative 2. Why? Because if I replace x with negative 2, the denominator will be 0, and anything divided by 0 is undefined. And if you are using the graph calculator, or if you know the graph of the reciprocal of 1 over x plus 2 all squared, you know that at the point negative 2, I have a line of asymptote, and the graph just drawing like this. So limit of x tends to negative 2 from the left is infinity, and from the right is infinity. So this is infinite continuity, if you remember the type of discontinuity that we wrote it yesterday. So this is infinite, okay, discontinuity, infinite continuity. The point of this continuity is what? Negative 2. But it's continuous, the function is continuous on the interval from negative infinity till negative 2 open, and from negative 2 to infinity open. For number 2, the function y is equal x plus 1 over x squared minus 4x plus 3, which can be written as x plus 1 divided by x minus 1 times x minus 3. So I have two discontinuity points. I have the function is discontinuous at 1 and 3. Why? Because I can't plug in x with 1 and 3. By the way, if you are using graphing calculator, you will find that at 1 and at 3 you have line of asymptote, and the graph is drawing like this if you are using graphing calculator. So it's continuous from negative infinity to 1, union from 1 to 3, union from 3 to infinity. Type of discontinuity here, you can consider it as infinite discontinuity. No, this is discontinuous. Why? Because you don't have here infinity, and I think it's a jump. I think it's a jump discontinuity here. For number 3, if you are using graphing calculator, you will figure out that the graph of 1 over x squared is like this, passing through the point 1. Okay, and this function cannot be 0. X squared plus 1 cannot be 0, as x squared cannot be or are always greater than or equal to what? To 0, as a positive value, So I know that all of the curve is above the x-axis cannot be 0. It will never intersect with the x-axis, by the way. So it's continuous for all the values from negative infinity to infinity. It's continuous for all the values from negative infinity to infinity. Number 4, y is equal to the absolute value of x minus 1. So if you are using the graphing calculator, this is the graph of x plus 1. So it's a continuous function on all the interval from negative infinity to infinity, as I can graph it without lifting the pen or the pencil from the paper. Okay, without lifting the pen or the pencil from the paper. Number 5, y is equal root of 2x plus 3. We all know that what belongs to the root should be greater than or equal to 0. So 2x is greater than negative 3. So x should be greater than negative 3 over 2. So the least value of the interval is negative 3 over 2. If you are using graphic calculator, we will figure out that the graph of negative 3 over 2 is drawing like this. Start from the point negative 1.5, which is negative 3 over 2. So the graph is continuous on the interval from negative 5 to what? To infinity. Before this, I don't know, there is no graph from negative infinity to negative 1.5. So, and there is no point of discontinuity. All the point below negative 1.5 is represent discontinuity for me. And notice that the root could be root of 0, and root of 0 is 0. It could be 0. It could be 0. The root, it could be 0. But there is a big difference between question number 5 and question number 6, as question number 5 is asking for the root, but question number 6 is asking for the cubic root, cubic root of 2x minus 1, cubic root of 2x minus 1. Below the cubic, you can have positive and negative value. Below the cubic you can have, so 2x minus 1 could be positive, could be negative, so it could be any value, it could be any number. From the graphing calculator, you will figure out that the graph of cubic root of 2x minus 1 is a curve that passes through the point half, intersect with the x-axis at the point half, and the y-axis I think at the point half also. Okay, and I graph the curve without lifting the pen or the pencil. So since I draw the graph without lifting the pencil, so the function is continuous for all the values. Continuous from negative infinity to infinity. So the difference between number 5 and number 6 is that number 5 is a root, but number 6 is a cubic root. Number 5 is a root, but number 6 is a cubic root. Any questions so far? Let's go to number 7. Regarding number 7, I have absolute value of x divided by x, absolute value of x divided by x. From the graphing of absolute value of x divided by x, you will figure out that it's 1, drawing like this, and at -1, drawing like that. Here is the origin, here is the x-axis, here is the point 1, here is the point -1. But it's easy, close or open at 1. If we replace x with 0, cannot be 0, as absolute value could having two values, x over x or -x over x. Okay, of course it cannot be 0, so I think these values are going to be open, it should be open. So it has a discontinuity at x equals 0. Let me check the graph. And x cannot be 0. This kind of discontinuity is a jump a jump discontinuity or a jump continuity, and x cannot be 0. So the point of discontinuity is 0, as x cannot be 0, and the function is continuous for all the values from -infinity to infinity except 0. So it cannot be written like this. I should write it as -infinity to 0 union from 0 to infinity. This for number 7. Let's prepare number 8. For what interval? I may ask myself, for what interval for the cotan? Regarding number 8, y is equal cotan x. The graph of cotan, if this is the origin, you are going to go to the point 90, and then at the point pi, which is 180, you are going to draw asymptote, and then at the point -pi over 2, and this is pi over 2, at the point -pi, you are going to draw asymptote, and the curve is drawing like this. So you have a discontinuity at each point that is pi or 2 pi or 3 pi. So each point with n pi. So this continues at x is equal n pi, whereas n belongs to the z integers. So it could be 1, -0. So for any point like 1 pi, 2 pi, 3 pi, all of these points I have discontinuity, and continuous between, if you want to write it for this interval, from -pi to 0 open union, regarding the graph here, okay, not regarding the whole graph, and from 0 to what? From 0 to pi. About the continuity, discontinuity. So I studied the continuity and discontinuity for cotan from -pi to pi as a range, from -pi to pi. Now let's go to number 9. E is a constant value. Its value is approximately 2.19. Regarding question number 9, of course, since y is equal e power 1 over x, I can't replace x with 0. So I'm sure that 0 is a point of discontinuity. Is a point of discontinuity. From the graph, if we plot the graphing calculator, if we add this function, the graph will be like this. Approximately so I have this continuous point or discontinuity at 0, but from negative infinity to 0 and from 0 to infinity the function is continuous. Last one, ln of x plus 1. Number 10, y is equal ln of x plus 1. We all know that the value of the ln should be greater than what? Should be greater than 0. Should be positive value. Could be 0? No. It should be greater than 0. So x should be greater than negative 1. And from the graphing, you will find that there is asymptote at the point negative 1. And the graph of the ln of x plus 1 is like this. So the point of as a point of discontinuity as a point of discontinuity, it's at x is equal to negative 1. Negative 1, this is a point. But as interval of discontinuous is from negative infinity to negative 1. But as continuous function, it's from negative 1 open to infinity. Bismillah ar-Rahman ar-Rahim. Regarding question 11 to 18. 11 and 18, I have a function. And it says that this function f of x is equal to x squared minus 1 for every number between negative 1 and 0. And 2x for any number between 0 and 1. And it's equal to 1 at x is equal to 1. negative 2x plus 4 when x greater than 1, smaller than 2, and 0 for any number between 2 and 3. And as we can see to the right here, that here is the graph of this function. Let's start with the first question. Does f of negative 1 is exist or not? F of negative 1, and if I'm looking for f of negative 1, I'm looking for a closed point. And here there is a closed point. So yes, f of negative 1, it exists. And f of negative 1 is equal to 0. Is limit of x approaches to negative 1 from the positive side exist? If I draw a line at negative 1 from the side, yes, it exists. And also limit of x approaches to negative 1 from the positive side is equal to 0. So is the limit equal to the function? Yes, the limit is equal to the function. So the function is continuous? Yes, the function is continuous at the point x is equal to negative 1. So to satisfy that a function is a continuous, I should prove that the limit from the left or the right is equal to the function itself. Now, regarding question number 12. Does f of 1 is exist? If we go to the point 1 and we search about the closed circle, we'll find the closed circle at 1. So yes, it exists, and f of 1 is equal to 1. Does the limit of x is exist? Yes, it exists, and the limit of x approaches to 1 is equal to 2. As you approaches from the negative and the positive, you meet the function at 2. Is the function equal to the limit? No, the function is not equal to the limit, because the function is equal to 1 and the limit is equal to 2. So is it continuous at equal to 1? No, it's not continuous, or we can write that it's discontinuous at x is equal to 1.
Determine whether f of x is a continuous at x is equal to negative 1. We know that the function could be continuous at negative 1 if the limit of x tends to negative 1 from the negative is equal to the same value of the limit of x tends to negative 1 from the positive side, and equal the limit of x tends to 1. And at the same time, f of x is equal the limit of x tends to negative 1, or f of negative 1 is equal to the limit. Yeah. Limit is equal to the function. So if I wanted to find the limit of x tends to negative 1 from the negative, so I need to plug it here. But if I plug it there, it will give me 0. But if I will take x as highest common factor, so it's gonna be what? It's gonna be x. So if I plug it with negative 1 or a number that nearest to negative 1 from the negative side, for example, negative 1.1, negative 1.2, you will find that it's approximately negative 1. So limit of negative 1 from the left hand side is negative 1. Now I wanted to find limit of x when it's greater than negative 1. So I gotta plug in here negative 1 instead of x, so negative 1 minus 4 over negative 1 minus 1, which is negative 5 over negative 2, which is 5 over 2, which is 2.5. So the function f of negative 1 as a function is 2.5. And as a limit from the positive side, a number greater than negative 1, for example, 0. If you figure out 0 is going to be negative 4 over 1. But what about 0.5 or negative 0.5 or negative 0.3? You will find that it approaches 2.5. So limit from negative 1 from the positive side is 2.5 or approaches 2.5, so there is no limit. So the limit is not equal to the function. So it's discontinuous at x is equal negative 1. It's discontinuous at x is equal negative 1, as the left value, when you plug in x with negative 1 on the left side, is not equal to the right side, is not equal to the function itself. Is not equal to the function itself. So for number 12, I wanted to find the limit of x tends to 6 from the negative, and limit of x tends to approaches 6 from the positive side, and limit of x tends to 6 and f of 6. If you wanted to find f of 6, It's the value at x is equal 6. So f of 6 is equal to what? Equal to 29. I wanted to find the figure out of f of x 6 tends to from the negative. So from the negative side, so in this one. So it's 6 squared minus 7, which is equal 36 minus 7, which is equal 29. And the limit of x tends to 6 from the positive side, I'm going to replace it here. 3 by 6, which is equal to 29. So the limit from the left is equal limit of the right. So the limit of x tends to 6 is 29. So the limit of x approaches 6 is equal the value of the function, which is equal to 29. So the function is continuous at x is equal what? Continuous at x is equal to what? Equal to 6. Determine whether the function below are continuous or discontinuous. If there exists discontinuity at the point, identify if it's removable or non-removable. And we have two cases for removable. Removable if I can replace the function with a value, or I can find the value of the function. So I will start by factorizing the function, so x minus 3 and x plus 3, and in the denominator I'm going to simplify, factorize, so it's x minus 10 and x plus 3. By cancelling x plus 3, so the function is x minus 3 over x minus 10. So it's clear for us that at 10, f of x does not exist. What about limit x approaches 10 for this function? What about x approaches 10 for this function? For example, from the left side or from the right side. By using the graph of this function, I will figure out that at 10, limit of x from the negative is approaches to negative infinity, and the limit of x approaches 10 from the positive side is infinity. So limit of x tends to 10 does not exist. The function does not exist and the limit does not exist. So this one is a discontinuity which is not removable. This infinite discontinuity. Infinite discontinuity. So it's not removable or non-removable. So this one is non-removable. Why? Because it's infinite discontinuity. I can't figure out the function or I can't figure out the limits. Regarding number B, I know that I can take the function and factorize the denominator. So x plus 1 is not factorizable, but in the denominator is going to be x plus 1 times x plus 5. So from the graph, at the point negative 1 and at the point negative 5, at x equal negative 5 or x is equal negative 1, f of x does not exist. F of x does not exist. So I need to figure out the limit. I need to figure out the limit. From the graph, at the point negative 5, I will find that limit of x tends to negative 5 from the negative is negative infinity. And limit of x tends to negative 5 from the positive side or approaches from the positive side is positive infinity. So limit of x tends to negative 5 for the function does not exist. And the same for the value of negative 1. Limit of x approaches negative 1 from the negative side is infinity. But limit of x tends to negative 1 from the positive side is negative infinity. So limit of x tends to negative 1 for the function does not exist. So the function does not exist and the limit does not exist. So this is non-removable. Non-removable.
In exercise 19 to 24, find each point of discontinuity and which of the discontinuous are removable, not removable. Give a reason for your answer. Let's start with question number 19. We know that we are discussing the continuity at the point 2. And to find the continuity of the point 2, I need to find f of 2, limit of x approaches 2 from the positive side, limit of x approaches 2 from the negative side, and at least one of these values, is equal to the limit. So limit of x approaches 2 from the negative for the function, and finally limit of x approaches to 2. It's clear that if I wanted to find limit of x approaches 2 from the positive, I'm going to replace 2 here. So 2 divided by 2 plus 1 is equal to 2. So f of 2 from the positive side is equal to 2. But if I wanted to find limit of x means approaches to 2 from the negative, I go to the smaller than. So 3 minus 2 is equal to 1. So the limit of 2 does not exist. Why? Because limit from the left side is not equal limit from the right side. And the function also does not exist. Why? Because the function, I don't have equality sign into the equality. Let's try to graph this one. If I wanted to graph this one, I will draw the x-axis and the y-axis. Here is the origin. Any number smaller than 2, so here is 2, 1. Any number smaller than 2 is 3 minus x. So let's plug in x was 2, 3 minus 2 is 1, and 1 is open. And then 3 minus 0 is 3. And so it's a straight line moving like this from the left side. And from the right side, 2 divided by 2 is 1, 1 and 2 is 2, so it starts with 2. And it's divided by 2 plus 1, so if I divide 3, it's going to be a straight line like this. So from the graph, it's clear that there isn't any close point and it's a jump discontinuity. Okay, so the type of this one is a jump discontinuity, not removable one. Let's go to question number 20 and the difference between 20 and 19. In question number 20, if I go into graph, I will figure out that it's the same graph when x is smaller than 2, so I'm going to replace 2 with 1, and I'm moving like this. And at x is equal to, the function is 2, a closed point. And when x is greater than 2, the value of the function is x over 2. So x2 over 2 is 1. So this is open. And 3 over 2 is 1.5, so it's going to be a graph like this. So I will figure out here that limit of x approaches to 2 is equal to 1. But the function f of 2 is equal to 2. So the limit is not equal to the function. Since the limit is not equal to the function, this continues at 2. So I have limit and I have function, but not equal to each other. In the first one, I don't have the limit and I don't have the function. Regarding question number 21 and question number 22. Let's start with 21. In question number 21, I have a piecewise function, 1 over x minus 1 when x is smaller than 1. And when x is greater than 1, it's x is power 3 minus x plus 1. First, I will find f of
1. And f of 1, I'm going to replace here x with 1. And this is give me 4. Notice that at the same time, this is greater than 1, so the limit of x approaches to 1 from the positive side is also, for the function, is also equal to 4. Now, I wanted to find the limit of the function when x approaches 1 from the negative side. When x approaches 1 from the negative side, it's equal to 1 over x minus 1, which is equal to negative infinity. Because if you replace x with 0.99, for example, it will give you a number which approximates negative infinity. Or it does not exist, at least. Why? Because you can't replace x with 1 from the negative side. But from the negative side, I prefer if you can replace 1 with 0.99. If you are smart enough, you know that the graph of this function here is doing like this. So limit from the left will give me negative infinity. But for this whole function, the graph is not exist at 1 because you can't replace at 1. At 1, the function is equal to 4. And from the right side is doing like this, but from the left side is doing like that. So is the function is continuous at equal to 1? No, the function discontinuous at x is equal to 1. Why? Because limit from the left is not equal limit from the right. Because limit of x approaches 1 for the function does not exist. So the limit is not equal to the function. The limit is not equal to the function. But I can say that this function is continuous when x is greater than 1. And this function is continuous when x smaller than 1. But at 1, the function is discontinuous. So I can write that the function is continuous at negative infinity to 1 or from 1 to infinity. But the function is discontinuous at 1. Second part, I have number 22, f of x is 1 minus x squared, and x equal negative 1 is equal to 2. So it's clear for us that f of negative 1 is equal to 2. And for any value which the function is not equal to negative 1, you are going to plug here. So the limit from the left and the limit from the right is following the same rule. So if I wanted to find the limit of x approaches negative 1, for this function, I'm going to replace x with negative 1 here, which is equal to 2. So the function is equal to the limit. And since the function is equal to the limit, so this function is continuous at x is equal to negative 1. Sorry, I have a mistake here. Negative 1 squared is 1 and 1 minus 1 is 0. So this function is discontinuous at x is equal to negative 1. If you are smart and you need to graph, the graph of 1 minus x squared is a parabola open downward passing through the point 1. And it says x doesn't equal negative 1, so there is a hole here at negative 1. At negative 1, the function is 2. So clearly, you will have a point here at 2, at negative 1. The function is 2, but the function is removable at x is equal negative 1. The function is not equal to the limit. Rahim, regarding question number 23, I have a graph function and I want to discuss the continuity and discontinuity at some values. First, let's start at points. For example, at the point negative 1. At point negative 1, the function is continuous. Why? Because the function is closed and the limit reached 1. At the point 0, the function is discontinuous. Why? Because the function is not equal to the limits. At the point 1, the function is discontinuous. Why? Because the limit is not equal to the function. And at the point 2, the function is continuous. Why it's continuous? Because the function is equal to the limit. But as interval, let's write here what is continuous The functions are continuous from the point -1 close to the point 0 open, and from the point 0 open to the point 1 open, and from the point 1 to the point 2 close, because I have the point 2. Otherwise, the function is discontinuous at the point at the point 0 and the point 1. Give reasons. The reasons here, discontinuous here, because limit of x approaches 0 for the function is not equal to the function of 0. Give a reason here, because the limit when x approaches 1 for the function is not equal to the function of 1.